Good morning. Thank you for being here. I'm not sure what's wrong with you people. I thought it was a fun town and you could do, partying late at night and all those kind of things. Actually, I thought this session was at 11:15 or 10:15 today. And then I was told yesterday night, as I was out, with Hans and others, it was about 11:30 p.m. that my session was at 8 or 8:30. So I don't know how you managed to be here. I barely made it. Also barely made it to this very, very, very north part of Madrid. I'm going to call it Barcelona, so far north that it's Barcelona. TechEd Barcelona, yeah, that's more fun. Anyway, welcome. It's a pleasure to have you here. We're going to talk about Link and we're going to talk about interoperability because we have a reasonably sized crowd. I'm going to try and keep this as interactive as I can. So we'll do questions and answers as much as I can during the session itself. There's definitely a number of points during the session where it makes sense to stop anyway because we're going to talk about principles, then we're going to talk about voice, then we'll talk about video. I've already signed up for voice interoperability and you get a premium, you get no extra charge video as well. So we'll have different sections and we'll certainly do questions and answers after each section. But if you want to, jump in at any point in time, please do. I'll repeat the questions before I move on. Before I get started, who has a direct experience implementing Link? Yeah, so you know all there is to know. There is nothing for me to tell you there. Who's implemented Link voice in interoperability? Wow, that's great. So I've done quite a few of these for a few years, unfortunately, and the gray hair and so on probably can attest to that. In the old days, when I would ask questions like this, the general answer from the audience was, what's Link? So we're improving slowly, but we're improving. Who's done video interoperability? Wow. Customers? Partners? So let me do it again. Customers, quite a few. Partners, a little bit more. Okay, great. So let's get started. Welcome. So here's what I'd like to try and touch on today with you. Some sort of an introduction on what are Microsoft's principles and investments with respect to interoperability with Link. We'll talk a little bit about what's new in voice interop. Now, one of the great news about voice interop or interop at large is it shouldn't change that much from one release to the other. If we broke everything from one release to the other, by definition, it wouldn't be interoperable. So for those of you who've done a lot of that before, that's not like we have so much that's so different in voice interop. But there's quite a few new things that are interesting. And then I think where we've the most progressed is in our understanding of how to use the technical toolkit for the right technical strategies. So that's what we're going to talk a little bit about as well. And then video interop is actually quite new in Link 2013. Who thought video interop was easy in Link 2010? Yeah, thought so as well. So hopefully next time when I say, who likes video interop in Link 2013, we'll have a lot of hands as well. That's kind of the agenda we'll try and follow. 3 big sections, an introduction, something about principles and the tools that we have. We'll talk briefly about Link and Skype Federation. It's a very special case of interop since it's now interop between Microsoft assets, but it's still very important. And then we'll dive a little bit into voice interop, talk about technical strategies, and have a little bit of a view at the technical toolkit. We can make this more strategic, more technical based on your questions, flexible. And then talk about video interop, which I think to most of you here is going to be quite new, Link 2013 being so different from what we did in Link 2010 and before. So let's get started. What we do in interoperability in Link is fundamentally by design. So sometimes you could think that interop is something that you do once you've designed a product and you look at, does this fit? Typically that won't fit. and it won't work. So what we do is we actually take the interrupt scenarios as design scenarios. And from the start, from the day one of the conceptualization, spec writing, development, working with partners, from the very, very early days, we look at the interrupt as a feature and as a capability, and we develop in that manner. That means that there are scenarios that we support and scenarios we don't support. The ones we've not designed for, we typically don't support. It's always tricky because you can do a lot of things. Do we have enough smart engineers, including in this room, to make something work or design something or conceive of something that we've not necessarily designed into the product? And our answer is going to be, well, we don't support that. The ones we support are those. They are scenarios that we believe are complete. We can do this and this and that. We have verified them. We test them. And as is the case for every feature we do, we have that long supportability commitment, the many years and the extended support and all those things. So that's why we have a very significant amount of structure around what we support in Interop. That persistence of scenarios across releases is super important. What we also do is we document our interoperability, and there's multiple ways that we work at that. One of the key ways is protocol documentation. You probably know that, but if you've not checked on that, in TechEd there is a section that looks at all of our client-server protocols, all of them, and including some for which we actually don't have a program for interoperability. If you want to have fun, you can actually build a new client for Link server, and replace our client completely. Everything's there. That's a lot of work. It has been done. Snum is a good example of a company that has done that with so happens to be a Linux embedded client. So it's absolutely feasible, but it's a lot of work. We also have APIs and a number of other things, and we have clean scenarios that are relatively simple, that are based in many cases on partner work. So we work with our partners alongside our partners throughout the development cycle to arrive at or about the time of release at certified solutions that support all the scenarios we built in. One of the ways we document that is through scale programs. So we have, in particular, a program called the UC Open Interoperability Program, which we now had for, I think, 7 or 8 years, something like that. And that program actually is the documentation of all the devices, tools, capabilities that are qualified against the supported scenarios. One key supported scenario that we'll talk a little bit about is direct SIP. Who knows what direct SIP is? Johan? Good. Yeah. So direct SIP, I'll talk a little bit more about what that is, but it's the definition of how we interoperate in SIP. It's very important to understand that definition, how the scenarios are built, and as a result, what you can do with it. And then when you go to a partner that's qualified, that's listed on the Open Interoperability Program page, you can know for sure that it's going to work the way we've designed it. So that's that approach, comprehensive approach we have, where there is a deterministic view of what's going to work. This is a little bit more detail on the Open Interoperability Program. It's got more and more chapters into it as time goes by. It used to be pretty much about one element of infrastructure, which was gateways. That's what we started with, and as well as some devices in the audio space, USB devices. That's what we had when we started 8 years ago. Now we have a very, very comprehensive program that includes, that's recent, session border controllers, but also we start to do some online interoperability capabilities, services qualification. For example, if you need an E911 routing service in the US, typically, and enhanced emergency services, we do qualify them as well. And our intent is to continue growing this and having as rich a portfolio as needed in order to support that. We have now combined the video interoperability program into the UC interoperability program as well, and I'll talk more about that later. So that's something that I encourage you to go visit. It's kind of boring on one side because there's a lot of information, but that's really the starting point for everything you do. This is just a quick example of the richness of what the program brings to bear as far as devices are concerned. That's only one of the elements that I had in the previous page. But I could show you gateway pages. And last time I checked, we had more than 50 gateways that were qualified in the program from as many as 13 different vendors, if I'm not mistaken. So that's a lot of choice and capabilities and differentiation you have at hand. So from the point of view of voice interoperability and vendor interoperability, but in particular voice interoperability, the infrastructure chapter of the Open Interop program, OIP, is probably the most significant, and that's where some of the most complex stuff lies. Interoperability with IPPBXs, interoperability with gateways, with SBCs, those kind of things. And you'll find a lot of things there. I want to draw your attention to the different terms, tested and qualified, because they make a huge difference. In a perfect world, everything would be qualified. What does qualify mean? It means that a vendor has come to us and partnered with us and has verified in independent testing. By the way, all of this is tested independently at partner labs. We have 2 partner labs. That vendor would have verified independently that they meet all the criteria. All the criteria. That's not, there is no subtlety there. It's binary. Meet all the criteria, including some criteria around supportability and processes around how we work with customers. That's the nirvana. That's the perfect situation. If you have one of those boxes that's qualified, or one of the solutions that's qualified, there's absolutely no doubt about what works. Unfortunately, there are competitive dynamics out there, and not everybody wants to partner all the time. So we have independently tested ourselves some solutions that we couldn't get the other party to come to the table all the way. And that's what you're going to find under tested. Now, the tested part typically doesn't meet all the criteria. It's very important to look at that because you'll find in many cases that, yes, it's listed there, but there is, doesn't support refer, doesn't support this, media bypass needs to be turned off, this and this and that. That leads to common mistakes of, well, it's listed, let's just do it. No, it's listed, let's look at the caveats, let's understand the impact of those caveats on the scenarios we actually want to put in place. And it might actually be much better to go use a gateway or a session border controller from one of our qualified partners and do media bypass to that gateway, or do a number of other scenarios that are much richer, or provide you more information on the wire afterwards. There's more information passed through. Is it me or is the light cycling? Okay, it's me. So I need to get my ass checked. Good. Learn something. So it's quite important to understand those things may or may not be optimal for you, even though they're listed. If they're qualified, they will be optimal in all cases. Last portion of my introduction, just a little bit of a small example of one investment in interoperability that we just did. I'm sure you're all familiar with the fact that we have introduced federation, including audio federation between Link and Skype. Who doesn't know about that? Nobody. Good. Who was too shy to raise their hand? So essentially what this enables people to do is to connect using the federation mechanism that you all know and love, that we've had for 8 or 9 years now, but to connect with somebody who's using Skype. We had federation with audio, IM presence and audio, and actually even video with Windows Live Messenger in the past, and it's been there for a long time. As you know, Windows Live Messenger is no longer around. We now have federation with Skype. There are some caveats which I'm going to describe. But essentially what you do is, in Link, just add a contact, and you're going to find a Skype icon, so no longer a Windows Live Messenger icon here, but the Skype icon. Add a contact. Just put in there the information. Now, what is that information? It's the Microsoft account of the Skype user. That means that we require a Microsoft account to be associated to the Skype account. We realized that not every Skype account has a Microsoft account, but that's the direction in which it's going, and that's what's needed in order to put that federation in place. Microsoft account. At that point, of course, you're going to have the contact. It's mentioned as external network, and if you were to expand the contact card, you would see that it's on Skype. If you want to call, you can make a link call to that person. Of course, you could do an instant message on presence as well. And you have your session here. On the other side, same thing. On the Skype side, they could add you. Of course, there are multiple layers of permission as always. There is an admin level of permission, and then there is the individual layer of permission for the link user to permit the external user to add them. A little bit of discussion amongst ourselves, since we are amongst friends, on what happens in the back. All the protocols on Link and Skype, when we got to see Skype, were different. Literally not a single protocol was the same. So converging the two is not an easy task. It's a Herculean development effort. That's one of the reasons we don't have video today. Different video codecs. Video transcoding is completely unmanageable at scale. We are managing to do voice transcoding in the service. One of the things that happens is the link side comes in encrypted in its own protocols, and then there is a back-to-back user agent somewhere on the cloud that we manage, that we offer for free, that is going to go from one set of protocols to the other, one set of codecs to the other. That's why we've been asked a lot, why don't we have video? That's really what's happening. As we converge the infrastructure, the protocols, the codecs, and so on for the two platforms, and as we emerge in the next generation of products and solutions and services, you'll find more covered in terms of the capabilities. But that's really where we are at this point in time. This is kind of the end of the first section, which has to do with principles of interoperability, and that's one example. Before I dive into voice interoperability, I want to pause a little bit and see if we have any questions at this point. By the way, you know that I have incentives for people who ask good questions. The incentives will be rewarded at the end of the session, but you can win them even now. So there's a good time to start. Questions on what we've had so far, or should I move on to voice interrupt? Yes.
Earlier we had to, if you wanted to add an IM contact, not on a Microsoft domain, you had to do that with a parenthesis. Is that still the case?
So the question had to do with, in the old days when we had, how do they call that? It's not courtesy domain, it's vanity domain, thanks. If you had vanity domains as a Windows Live Messenger account, you had parentheses in the way you had to enter it. Microsoft accounts, as far as I know, don't have that anymore. So my understanding of the way a Microsoft account functions is that it's a normally formed user@domain.com URL. And I'm not aware of having any vanity domain requirements in terms of parentheses anymore. Could be wrong, but I'm not aware of it.
What about interoperability with Azure, sorry, not Azure, Office 365 using Link Online? I've read somewhere that they're depreciating the hybrid model.
So there's two questions in your question. The first one is, what about interoperability with Link Online? And everything I've described here, at least on this slide, is valid for Link Online. Federation with Link Online is obviously open, something you can add, you can control from your Link Online control portal. So you can decide to open federation, and you can decide to restrict it to specific users or domains. So that's in the control panel on Link Online. With respect to hybrid voice, it's a different topic. Time permitting, I'll address it at the end of the session, but it's not to do with interop itself, so I'll put it aside. But it's correct that we no longer offer hybrid voice, which had not been deployed anyway, so it's not been impacting any customer. I'm sorry, I can barely hear you. Sorry. Is there a difference between beta client and full client? Between the basic client, sorry. The basic client and the full client on that with respect to federation. Not to my knowledge. I can verify that, but not to my knowledge.
And we tested that we can't see Skype.
That would be my understanding.
And so when we register to full client, then we see Link and Skype, and it's crazy.
So I don't know the answer to the question of whether there is any difference between Link Basic. I don't think there is one, but we need to verify that and take that aside. Because if there is a difference, I'm not aware of it. If somebody from Microsoft in the room happens to know that, no. So we'll verify that. Yeah, Link Basic Client is a client that is provided primarily for licensing purposes for people who don't have rights to Office 2013 at large in order to use Link Online and things like that. And normally, there shouldn't be significant functional differences. It's licensing elements, but to be verified. Okay, so moving on to, yeah? Is there a way to blacklist or whitelist Skype users? Not at this point in time. However, the use of the Microsoft account is one of the rationales or one of the things that would help us create this going forward. Now, on an individual basis, you can block users, obviously.
Is it possible to make it one way, so you can add a Skype user, but Skype users can't add?
So is it possible to make it one way, so you can add a Skype user, but they cannot add you? Not quite, but you can. The Skype user has to request your permission, so you can essentially deny that or ignore them. And in Link 2013, in your contact list, there are multiple sub-panels there, and one of them is essentially the new requests or the new contacts that have been submitted to you, and you can review them in one single place. Okay? Moving on to voice interoperability. We'll start with some of the principles and scenarios. In my view, interoperability typically fails when the scenario, the technical strategy is wrong. It's not a technical issue typically. We've tried to choose a scenario that's the wrong scenario either for the user or in light of what we support. When we have the right technical strategy, it systematically works very, very well, and we have many, many, many examples of that. So it's a very important thing that typically gets underlooked, that thinking about what we want to achieve in this case is probably as important or more than the how we eventually achieve it. The how, hopefully we've taken care of that for you in terms of having the appropriate partner solutions or documented solutions in place, and we have hundreds upon hundreds of deployments of those type of things. We find that the ones that typically come back as being problems are the ones that the scenario is not the right one, not scenarios that we've built in or things that we believe just don't make sense. One of the things that really goes with that is, what is the goal of your enterprise voice deployment? Sometimes the goal is a very rapid replacement of all the PBX assets, and that's fine. Sometimes it's more enablement of users, and we are not as much preoccupied about retiring the PBX assets, at least not in short term. There might be very long coexistence, or there might be as quick as possible migration through that. That actually can drive differences in the way you approach your technical strategy, and as such, the topology of the implementation itself. When PBX replacement is the primary objective, typically what we see working best is a very immediate replacement of the solution per user and per group of users and per homogeneous group of users and per site if possible. That's not always possible either because of investment cycles or because of politics or other type of things. The other type of deployment that we see is what we call overlay. I don't care that you have a phone on your desk. It doesn't really matter. It can gather dust as much as I'm concerned, but it's none of my business. What's really useful is that I can enable you or your users with Link, and if you like it, you'll use it. I don't care that you have another one on your desk. I don't care that you have a mobile device. I don't care that you have possibly 5 different phones on your desk. If we give you link and you can use it to your advantage and you actually like it, then we've satisfied the most important part of the mission. That approach of overlay is one option that people don't always consider. Or when they consider it, they sometimes consider it in an implementation mechanism that's not as effective. Making that choice up front of what it is you want to achieve and for whom. For example, you might have a situation where you say, this site, the PBX, is beyond its support lifecycle. We're actually going to replace it. Other sites, we're not ready yet. Well, what if we gave them link voice anyway as an added capability? Why not? Those guys we're going to replace, those guys will give them link voice, that way they're all homogeneous. But those guys might still have PBX phones, not a problem. Those types of approaches, determining them up front, is actually probably more critical than how you're going to implement it. Now, overlay, you can do it in 2 different ways. One of the ways is, and I said earlier, you can keep the phone on the desk. Just push it as far back as you can. Or in the old days, we actually had a trick. We put it under the desk. So if you really feel like you want to use it, it's still there. The idea is the behavior of human beings, tends to be very ingrained, and for those of us who are righties, lefties probably the reverse, they reach out to the phone. Oh, it does that all the time. At least for the first few weeks that you get migrated to Link. So we're trying to give people the opportunity to really get used to Link. But there is other things that I'm going to detail that make having a phone on the desk and Link at the same time a little bit complicated. Do you give people 2 DIDs? Do you give them the same DID and how you coordinate? And when a call comes in, how do you manage it? So we have some recommendations that I'm going to detail for you next slide. The preference still is you keep the PBX infrastructure on site if you're going to do overlay. But for those people that get migrated to Link, just do a forwarding or a mapping of their DID from the PBX to Link. That's what we found to be the most effective in terms of short-term migration, because infrastructure can take a little bit longer. So you can actually take care of the users, not the infrastructure dimension. As you know, PBX does essentially 2 big things. It serves users with user-centric functions, and it serves the infrastructure with infrastructure elements, analog lines, faxes, all sorts of things like this. So you can actually kind of decide, let me take care of the users, I'll come back in a few weeks and do the infrastructure later. Migration approach. Yeah? So in those overlay cases, what I see a lot of customers do is they say, I'm not sure we're so ready for Link, so let's try and do belt and suspenders. Let's do both of those things at the same time. We'll keep the phone, we'll get Link, and then we'll get everything to ring. That way they choose. That's one of the ways to fail with the deployment. And of the very few voice coexistence deployment I've seen that did not succeed, at least initially, all of them, almost all of them, were in that category. Why? Because it's highly confusing to the end users, because scenarios are not predictable, and because you can lose calls, and I explain that. So don't do simulring, don't do forking, dual forking, whatever. We don't support that, for one thing. It's not a supported scenario. It's not in the product. It's not clean. It's highly confusing. Examples. Let's say I work with somebody who supports me, an administrative assistant. A call comes in. I'm here, so I happen to be on Link because I'm not in front of my desk with a hard phone. My admin assistant happens to be in our office, and because, habits are habits, might prefer to use the phone and might not even be logged into Link. So if a call comes in, we have a boss and an admin on different systems. Guess what? Boss admin scenarios are proprietary. It's not because any vendor is bad. That's just life. That's the way they are. There is no universal standard to do boss admin scenarios. So if a call comes in, we don't have a boss admin scenario. If she picks it up, tries to transfer it to me, it's broken. We might lose the call, or who knows what happens. Or she needs to do some completely different thing to transfer it to me. If I pick it up and then I want to send it back to her, no way. No shared line appearance, of course, nothing. Yeah? So this is one example. Voicemail, another example. Yet another example. If I actually want to call somebody from Link, let's say my admin, and again, because, let's say she's a little bit old-fashioned in that case, she would not be logged into Link. Just the traditional phone on the desk. And we expect all calls to come to both, so it doesn't matter which one I'm on. Yeah? If I'm in Link, Link does what we call a reverse number lookup when I call out. So if I call my admin assistant, Link says, oh, even though you typed that number, what you really wanted was that person. I see that person has an account on Link. Let me ring Link. Well, that person is not connected on Link, so happens to go to voicemail. So every time I call her, even though she's at her desk by her phone waiting for me to call her, I end up in her voicemail. And it's not even the voicemail of the phone. It's a different voicemail exchanged in unified messaging on her email, which she may or may not check. So we have those completely broken scenarios. That's one of the best ways to screw up a deployment. So don't do those forking things. So how do you do it then? Well, one of the great ways, as I mentioned earlier, is to remove the PBX phone. But if you don't want to remove the PBX phone for political reasons or perception reasons, why not do a permanent forwarding at the PBX level? You can do that in practice either with the same DID, there's some mapping things that you can do, or with two different DIDs, so do two different phone numbers. Yeah? But either way, what you do is you permanently forward the PBX phone. The PBX phone will no longer ring, but it's still there. If in the extraordinary case that Link would not be available, down or whatever, which I don't think there's any reason for that, but that's the question that you get asked. What if it's down? Oh, I can always pick up my phone. I could unforward it if we needed. I still have it. But the advantage is it's no longer my primary phone and my primary experience. I'm now on Link. And that's what we recommend as a mechanism of coexistence if you want to have both of those things at the same time. That's a scenario that works well, that we've documented, that we know how to make function. That said, it's not a long-term solution. Eventually, you want the phone to go away in that type of situation. The PBX might or might not be in the back. That doesn't really matter. And eventually, you remove the PBX. One of the ways to do that is through the use of our partners' qualified gateways. That will support fax and all those kind of things. By the way, you can interrupt me at any time, but I'll pause after the voice section in probably about 5 minutes or so, 5-10 minutes or so, and we'll talk a little bit more. So this is kind of the summary. Pick one, belt or suspenders. The two systems at the same time for a given user, eventually that's going to be too confusing. Do that permanent forwarding, or remove the phone even though you may not remove the PBX, and again, permanent forwarding at the PBX. Remote call control. Who uses remote call control in the room? I'm glad that there are fewer and fewer hands every year, but you gentlemen are in trouble. No longer advisable. Strongly advisable to move away from it now, before it's potentially no longer there. There's a lot of reasons. If you want, I can detail them. They're on the slides. You can go back to them. But essentially, this is outdated technology. It's no longer consistent with the rich scenarios we build into the solution. When you use remote call control, you might be using less than 1% of the lines of codes that we put in the product. That's quite expensive to throw away 99% of the product. And the best remote call control solution we ever did was called Live Communication Server 2005 SP1. So if you really want remote call control, that's what you should be using. It's the message. May or may not be a fun one, but we need to move away from it. Let's talk a little bit and briefly about the technical toolkit that we have in Link 2013 from a voice point of view. There's a number of new features from a voice aspect. Now, I've put them in two categories. some that would significantly potentially impact your technical strategy. And there is only one there, and that's the inter-trunk routing, and we'll talk a little bit more about that. Then there is features around how you can improve or change some of the things that you do within that technical strategy. Calling number translation, for example, a nice feature. You know, before that, you probably needed to do it on a gateway, on trunk, or whatever. So we are in a better situation there. We have more resiliency with M2N routing and the trunk definition. And there's a lot of those little things. I'm not going to go in detail through that. If you have questions, we can take them. But that's not the primary goal here. But there's a lot of nice little things that when you go into the doc and look at it in great detail, you'll find, wow, this actually helps. My resiliency is substantially improved because of all the things I have here. You know, where is it? Yeah, the bidirectional options, for example, that's going to be helpful in terms of improving the resiliency as well. I can do a lot of little things that eventually are a good thing. But the one that really changes potentially my technical strategies here. Another thing is, you might look at the OIP, the Open Interoperability Program page, and see that, wow, I don't see that many gateways or IP PBXs or whatever qualified yet for Link 2013. And I'm deploying Link 2013. How do I do that? You don't have anything qualified. So there's a number of things that are important. One, solutions that were qualified with the Link 2010 level of capability, in all likelihood, are also going to function at the Link 2010 level of capability, at least with Link 2013. Now, it's not yet official, so you might not want to go there. Another possibility is you might use a 2010 mediation server, and I'll show you a little bit more of that in a second. So you can, if you use a Link 2010 mediation server with a Link 2013 pool, then you can use all the 2010 qualified solutions at the 2010 capability, and then once they get upgraded, you have the opportunity to upgrade your mediation server. When will X solution be qualified for 2013? The answer is almost always very, very soon. We have a ton of them in the pipe right now. Some of them are starting to make their way to the page. If you have specific one-off questions and you're really pressed for time, you may want to approach the partner or approach us, and we might be able to tell you, whether it's almost done or not. But by and large, all of them are in the pipe right now. We're also doing some internal PBX testing, not for the qualified dimension that I described earlier, but for the tested dimension, and verifying what is going to work. This is still in progress, but they're all coming. Essentially, the scope is not going to be different from what you saw in 2010. Where the solution didn't support refer, it still doesn't support refer. Where it didn't support media bypass, it still won't support media bypass. So in all likelihood, we expect the same caveats. This table here is actually a supportability matrix for what works if you were to use a combination of 2010 and 2013. It's actually quite useful in looking at the fact that you could have, for example, 2013 pools and either using 2010 or even R2 mediation servers, and combine that in order to use gateways or other solutions that are currently qualified at, for example, the 2010 level of support. That's same thing for SBAs. So it's quite useful from the point of view of being able to start your deployment now before we have a list of supportability of supported gateways in a few weeks or a few months. I'm going to pass relatively quickly on direct SIP because we pretty much all know what it is. But direct SIP is really more than just a protocol. Yes, SIP, and there's some specific elements in protocol. It's also a process. It's a process for testing. It's a process for the end-to-end management of the interoperability. And you'll find that it's very well documented on the OIP. This is what I was mentioning earlier. Your peer is listed. Yeah, it's tested. We tested this, and this is OXC 9, yeah? 9.1. And you find, you need to disable all of those things. Does it make sense to try and do direct SIP with all those things disabled? Well, it kind of works, but then you lose a lot of the value-add features and so on. Why not use one of the gateways from one of our qualified partners that will give you a much richer interoperability and something that's actually much better from a manageability point of view, in some cases reporting as well. Inter-trunk routing. So that's this new thing that we have in Link 2013 that really can change the way you do deployment. Essentially what it does, you probably know that before, if you were to deploy Link in parallel with a PBX, you could never front the PSTN with Link. You could never have Link as your first hop from the PSTN. The reason for that was that Link was not able to route calls that were not meant for it to a PBX. So either you would do it with a gateway, and the gateway would then have the intelligence and the logic to say, well, this is meant for Link, this is meant for the PBX, but then you needed to have one more place where you manage those things. Or you put the PBX in front and send calls to Link, which was very much okay because Link was probably considered young and immature and all those things. Now Link is probably in a very different phase where we actually have massive voice deployment and credibility in the space, and it might be appropriate in some cases to use Link as your first hop. If you're going to make that migration happen, why not? Also, if you have a situation, a customer that has multiple traditional PBXs and has not yet been IP enabled, you can actually IP enable them with Link, doing literally toll bypass using Link, with the old PBXs, and I'll show you that in a second. So that's quite interesting. Now you can start with Link as your first hop, either through a SIP trunk or through one of our qualified gateway partners, and direct traffic to PBXs from there. The last point I want to make, this is not to be confused with a full-blown SBC or full-blown gateway capability from our partners. And what I want to mean by that is, if you are looking at a small-scale deployment and something for which an SBC would be cost prohibitive, it makes a ton of sense to use this. But if you're doing a real, enterprise large-scale deployment where the cost of an SBC or a qualified gateway is really not a prohibitive element, they might have other capabilities there, packet inspection and other type of routing elements that we don't have and we will never intend to have here. We are not trying to build an SBC. This is one more capability, especially valid for smaller deployments. So what can you do with it? Well, here's an example. You have the PSTN ingress, one of the qualified gateways, from our partners. There is a trunk, a simple trunk that goes to mediation server. Of course, you could have resiliency. It's not represented here. And you have Link here. But you had an old PBX, and for some reasons, you still need to have a few people of the PBX. You can actually put that PBX hanging off of Link, and when a call comes in from the PSTN that should be directed to one of those phones, Link will make the decision to send it here. You don't need to build the logic here or here. All the logic is here from that inbound routing. Yeah? This one is the other opportunity that I mentioned earlier. You can actually do PBX networking, regardless of whether the ingress is here on the PBX or at the mediation server. Doesn't really matter where the ingress is. But you could have multiple PBXs that have not been IP networked yet. There's few of them out there, fewer and fewer. But you can actually IP network your old PBXs with Link, start the deployment of Link, and progressively, obviously, probably start removing some of those PBX phones. So that's one of the many things that could change, that you could actually be more effective with Link 2013. I'm going to do a brief reminder of media bypass. Who understands media bypass here? Probably about a third of the hands. Media bypass is a feature that's quite useful when you have a coexistence of Link and, for example, an IP PBX in branches, and when you have a central deployment. One of the concerns would be that if I'm trying to talk to my friend here, my friend happens to be on a Cisco phone, I happen to be on Link, our media would go all the way to the central office and back and trombone on the WAN, which of course is quite inefficient. In order to avoid that, we have this feature called media bypass, which is supported with a variety of solutions, including all of our qualified gateways from our partners. Okay, so this is what this represents. Media bypass, very simple. The signaling always goes through link and to the PBX. It needs to be an Open Interoperability Program qualified PBX. The media, however, does not go through link. So the media could actually be direct to the PBX, not to the endpoint. I can talk a little bit more about why not to the endpoint, but essentially it's not to the endpoint, it's to a media termination point that will be on the PBX or on the gateway. You know what? I'm going to, in the interest of time and not boring you too much, try and go relatively quick there and rather take you through the slides that show the flow. Essentially what it is, it's dynamic. So it actually knows in real time where your client is located. If you're located close to the phone that you want to do bypass to, the bypass will be enabled automatically. If not, if you're traveling, it will not be enabled. So this is your functional topology. You have a headquarters site. In this headquarters site, you have, I thought I had, yeah, okay. You have the link deployment with the front ends, the mediation server. You also have, in this case, a call manager. It has what they call a media termination point, which is essentially a little bit like a mediation server. It's a point where the media will be terminated, will be aggregated and terminated, and phones. If you're in the same location here, you should be able to do media directly without going through the mediation server. You also have branch offices where you have phones and link. And here as well, if you're in the same location, the media should not go through the WAN. That's what happens. So first thing, a call across the WAN. There is no media bypass. It actually goes through the mediation server. We use the appropriate codec, which is going to be, in this case, in all likelihood, the RT audio codec. That's going to be based on, in particular, round trip time or the call emission control policies. So this, not a media bypass, we do transcoding. If you're in the same location, though, so it's the same person making a call to a phone that happens to be local, we will dynamically be able to make the determination to send the media to the Cisco router that you have on the site. So typically you have a Cisco router, an ISR, or you might have one of our gateway partners there. You might have, a Ferrari gateway or another of our partners' gateways here. Yeah? And you can do media directly in G711 to that gateway and then to the phone. So that means that there is no media across your WAN. If you were to lose your WAN, the media will remain up. This is what happens here. You no longer have the signaling, so you cannot control your call during that call, but your media remains up. If you had a survivable branch appliance here, so instead of having just the Cisco router, you actually had a survivable branch appliance from one of our partners, you could actually even establish the call and maintain control of the call during this situation. You could also use this router or this gateway as your PSTN ingress and egress. So this is a situation where you can have a deployment where the media remains local to the branch, coexisting with, in this case, a Cisco phone, with almost no infrastructure, no link infrastructure on the site, either zero infrastructure or just a survivable branch appliance. Just drop the clients and possibly the survivable branch appliance, and your media will remain local. This is the feature that has enabled us to convince some very large customers, oil and gas customers, hundreds of thousands of Cisco phones deployed, to start deploying Link and to start the replacement process of Cisco with Link. It's today proven in deployments at some of those large customers. Literally, 6 digits, Cisco phones, Cisco IP phones in place. A replacement program that's probably going to take 5 years or more, with Link progressively being dropped into the infrastructure, and of course cannot afford to have back and forth on the WAN. So it's a very interesting feature from that point of view if you're managing this type of long-haul coexistence and need to make sure that you manage your WAN properly. Question. So this is actually a good point because I'm finishing the voice section and we're going to talk about video rapidly afterwards. I'll take questions on voice. Yes, go ahead.
You state here that the call stays up. This means that the call which is happening will keep up. But a new call can also start.
So if you want a new call, what you're going to need to do is to have here a survivable branch appliance, which is an appliance that has link capabilities that could be a gateway as well. It could be used as a gateway as well. So you could actually have PST and ingress or egress here, or the survivable branch appliance could talk to the ISR and ingress and egress from the PSTN here. So if you want to be able to maintain signaling control and establish new calls, we have a solution for that as well, but it will require a small amount of infrastructure on site.
What was the reason to abandon hybrid voice scenarios?
So the hybrid voice scenario, same question, same thing. I will talk about this later because it's not an interoperability question. And I will want to manage my time on interoperability first, but I'll stick around and talk about that later. Voice interoperability, yeah.
I would like to ask about this scenario that you described here. I know with Link 2010, it was rather difficult to set up this because you would have to have multiple trunks or a single trunk to the call manager. But if you have multiple ISRs in the branch offices, then the media bypass would not necessarily.
So the question has to do with the setup. First, this is actually probably the single most complicated feature in Link to understand. The setup is actually not, it's on one side extremely simple, but the thought process that goes with that is quite advanced. You mentioned that you need to set multiple trunks. That's actually not true. The trunks are set dynamically. We use virtual gateways and something called the representative IP address of a site. We get the actual IP address of the gateways, of the Cisco gateways, or in this case Cisco, whatever is the endpoint, dynamically from the SDP. What this means is Link doesn't need to maintain a table of the IP addresses and the Link and the Cisco infrastructure. That's very important because imagine if you were in a situation where somebody, your Cisco admin changes some gateways. You know, one is up, one is down, doing maintenance, putting one more for capacity planning, re-IPing, whatever. You would need to change a table in Link. That's just completely unmanageable. None of that is required. The way this works is actually through the dynamic SIP negotiation, we actually get the specific IP address of the media termination point we need to send it to. The only thing we need to know is the signaling endpoint, this IP address. Everything else will come in the signaling. So actually, and contrary to what you were saying, sorry, you don't need to design all of those things with all the IP addresses of those routers. They will be communicated to us in real time by the Cisco infrastructure.
So the reason why I'm asking is when you enable media bypass, you also have to enable centralized media processing.
Yep.
That contradicts to the way you are describing it, or at least in Link 2010.
It's essentially the same principle in Link 2013. There's no fundamental change in Link 2013, and I would encourage you. We can spend a little bit more time on the booth if you want. We can show you how it's done, or we can discuss with Adam Gent as well, who's probably the world's single most expert on this. But you actually don't need to have a detailed description of your Cisco infrastructure. The only thing you need to know is in which subnet collection, in the sense of the Link call emission control sites, the gateway might be. So that's all you need. You need for this site one representative IP address, which that's all you need to make this happen. And virtual gateways definition. Yeah.
Could you elaborate a little bit more about the remote call control in the future?
So it's a question about remote call control. What's your question specifically?
You said something that it's not part of the future.
Yep. Yep. And so we've been saying this for a period of time. Sure, people who've heard me before have heard me say that before. I'm trying to make it even more obvious. Remote call control is something that was designed and developed around 2003, 2004. Since that time, there's the grand total of 0 additional capabilities or, engineering value-add capabilities brought to it. At the time we developed it, it was designed for about 3 years. It was designed for a period of transition until we introduced enterprise voice. None of the other investments we're making, like audio and video on the mobile phones, the richness of the collaboration and conferencing capabilities we have, all those things. None of that works with remote call control. It's completely orthogonal. And so it's incompatible with the way we function. It's also something that, from a cost management point of view, is not satisfactory because it requires to maintain link, pay for link, maintain the PBX, pay for the PBX, and maintain an interoperability which is complex. It's difficult to operate at scale. Now, small deployments, yeah, it's feasible, but it's difficult to operate at scale. All of the large deployments we've seen people have tried have failed. We did surveys and we tried to find out who was on it, and we found that probably less than 1% of all the lines we have are on it, were on it when we did the survey about 18 months ago. It's less today. And so it's something that's no longer used by our customers in a statistically representative manner, probably was never really deployed by most customers. We found a few, but most of them had difficulties and have moved away from it.
What about QoS and Link?
What about QoS and Link?
When is it recommended, when not?
Oh, QoS, yeah. So this is not about interoperability stricto sensu. So I'm going to set it aside, come back to you after the session, talk about it if you want. But we support QoS, DSCP, and we certainly recommend using it if people can use it.
What about if PBX has like a single number function across desk phones and mobile phones? How does Link fit in there when you're trying to integrate them?
So the question has to do with what if the PBX has a single number function? And how do you put Link in there? So that's a very good question, because that's where we see people want to say, well, we're going to use Link as one of those things and we're going to do forking and it's going to ring this and that. That's where it breaks the most. That's where it's the most of a nightmare, because essentially you have completely unpredictable scenarios. You never know what to happen. All of the basic feature will work most of the time, but even things like voicemail will not, and things like consultative transfer and all those things, that's going to break down all the time. The mistake is people think, oh, it's not very important. Those features are value-add features. They're not that important. It changes as soon as people use them, yeah? So I completely advise against that. Essentially, at some point, you're going to make a decision. What do I use Link for? If I'm going to start deploying Link and using it to provide enterprise voice capabilities, it's important to, in the same way that it was important to do it cleanly for the PBX before, it's important to do it cleanly for Link now. I'm going to move on to video because I'm probably going to be in a little bit of tight note here. We're going to fly through video. So what's our video strategy and what's different in Link 2013? So our video strategy is really to enable video on any endpoint, anytime, anywhere. Video for a long time has been about video conference rooms. That's a place where you go. That's no longer the requirement of our customers. Our customers want video not to be a destination, but to be something they can do on any device that they already own, and with a lot of interoperability. That's what Link 2013 enables you to do. So we do a lot of activities in that space. If you go to the booth, you'll see what we propose for the conference room, because the conference room is one of the elements, but the conference room is only one of the elements. It's not just about the conference room. It's about Link on PCs, on Macs, on iPads, on browsers, on mobile devices, and so on.
When is Link ready for WebRTC?
Different question. I'll take that a little bit later. I would rather put it the other way, when it was WebRTC ready. So let's table that, but I'll go back to it. From an interoperability point of view, there's a lot of assets in place today. Most enterprises have video conference rooms, and clearly we need to find a way to work with those video conference rooms. So the investments we made in Link 2013 really fit into that. We have video qualification programs. I'm not going to spend much time on it, but they're essentially designed around several pillars. There is endpoints, there is MCUs, and then there is gateways. And those gateways are clearly to connect things together. You'll find a variety of players there. One of them is Avaya with Red Vision, Polycom, Lifesize, and so on. Going forward, we believe that video endpoints and gateways, in the sense of signaling gateways, are going to be the two most important ones. What did we have in Link 2010 from a video point of view? Well, we could do point-to-point in Link, as well as in terms of interoperability, 720p, and we used the RT video codec. There's a few more things there, and we did active speaker. In Link 2013, video is very, very different. First, we've changed our codec. Why did we change the codec? We use H.264 SVC. When we started using RT video, we started developing RT video about 7 years ago. At the time, we looked at the codecs that were available on the marketplace. And we just couldn't find any that met the needs that we had. In particular, they were mostly optimized for well-managed networks. When you put them on internet, they behaved in very unsatisfactory manners. Their scalability was not satisfactory. You couldn't do scalable video codec in the sense of multi-rates that you could peel off one of the other. And so we decided to build our own because we couldn't find the one we wanted in the marketplace. And what we tried to do is to standardize that. So we actually did standardize it, but a standard is not just something that's in a standard forum, it's something that's used by people. And we failed at that, so people didn't really broadly adopt it. As a result, we decided that that didn't work because we are committed to interoperability, we switched codecs. The way we did this is we worked with the vast majority of the industry through the Unified Communication Interoperability Forum. That has more than 50 key players there. You know, people like Avaya there, Polycom, Intel, Broadcom, and all those type of people. Why is that important? It's important because you have every player from the foundries, you know, the chipsets, all the way to even service providers like Video and Blue Jeans. And all of the key players in video in the enterprise, Lifesize, Polycom, Red Vision, and so on. That enabled us to have an industry-wide agreement. There's one player that's missing from the list, unfortunately, but at least everybody else agreed on one strategy. We all agreed on this one new codec that Polycom and Video strongly contributed, Microsoft as well and others, but you know, to a large extent, it's great credits to those guys. One single codec that the entire industry is embracing. And we got that standardized at the ITUT about a year and a half ago. That's the codec that we're all using forward. Why is it important? It's because that codec, and actually I think it's probably more, sorry, that codec is actually backwards compatible with the codec that exists today in pretty much everything you own. Your video conference rooms talk in H.264 AVC, which is something that an H.264 SVC solution is capable of doing. Your iPad out there, your Windows Phone here, and so on, they all have H.264 embedded today. They don't necessarily have H.264 SVC yet. It will come, because we have the commitment from the foundries to do that. But they have H.264 AVC, and we have backwards compatibility. So by doing this, we bought interoperability with pretty much everything in the world. For example, mobile devices. So everything that has ARM chipsets or other, you know, type of chipsets today, we are able to do it. So Link 2013 Mobile fully supports audio and video, with video backwards compatible in most cases today on H.264 with chipset encoding. In the old days, in order to do some 720p video with Link, you needed a quad-core. Now you can do HD video on something that's about that big, yeah? Big change. But you can also now do video interoperability with your existing room systems that you have deployed that use H.264 AVC without transcoding. That makes a huge difference. Not going to spend too much time, you have the detail here, but one of the things that we're able to do with SVC is multi-view. So we're now providing multiple parallel streams of video to end users on browsers. I'll talk about WebRTC in a few seconds. On browsers, we support audio and video on Safari, on Firefox, on Chrome, on Internet Explorer, obviously. So all of those are on browsers as well as on full clients, as well as on your Surface tablet that I'm sure you enjoy, love and enjoy. So you can actually see all those multi-views. We couldn't do this without that new standard SVC. It gives us the scalability to do video for essentially all of your users in your deployment completely on the same infrastructure that runs Link today. If you were to do this in a hardware-based mode, it would take thousands of ports, which typically hardware ports, not inexpensive, thousands or tens of thousands of dollars. So that's a big difference, and that's really how video interoperability is going to change, because we now have the opportunity to bring in all of those conference rooms, all of those mobile devices into the Link conference from a video point of view, together with the Link room systems you've seen on the booth, together with browsers and full clients. Where is WebRTC in this? WebRTC today doesn't support H.264, so it's not compatible with any of the enterprise solutions. WebRTC today is trying to determine whether it's going to support VC8 or VC9, and it's possibly looking at whether H.264 could be part of that going forward. Part of the problem is if WebRTC is based on VC8 or VC9, and your rooms only talk H.264, in order to get those together, you're going to need to transcode each and every stream, which is not feasible at scale. It's okay for a few streams. If you want to bring one browser into a conference, that's okay. If you want to enable tens of thousands of users on any device they own to do video all the time, or at will, that's not going to work. So where is Microsoft in that? Microsoft participates in the WebRTC standardization. We actually contributed the audio codec. The audio codec is a contribution from Microsoft. We're trying to sort through the video piece. We would prefer to see compatibility with enterprise assets there. We certainly prefer to see H.264 SVC there, or H.264 SVC compatibility, one way or the other. We have committed that as soon as WebRTC is finalized, we will implement it and support it in Link. Part of the problem is it may not provide us as much capability as what we do today on browsers. What we do on browsers today is done through a plugin that has rich media stacks. That plugin is about 5 to 7 megs, so it's a small plugin. It doesn't require admin rights. It's not an ActiveX. It's a browser plugin. WebRTC would enable to do that plugin-less, which would be favorable. But then if it doesn't support the right codec or doesn't do it with the right quality, then it's not helpful. So what might happen is a coexistence of, well, you can do it without a plugin, but you won't get the full range of capabilities, such as the multi-view, by the way. Or you can do it with the plugin, which is a small footprint plugin, and you get all the range. That's the more likely outcome at this point. I suggest we, given my time situation, that we finish this afterwards. But I think I answered the what with WebRTC. I would say at this point, WebRTC is not designed as an enterprise-centric solution. It's designed as a consumer-centric solution. And there's good and bad things with that. But it means that from a video point of view, there is no very clear path to make it, to connecting it with any of your assets today. We've removed H.263 in Link 2013. The primary reason is it's very poor quality. It's not needed for interoperability. You might hear that it's needed for interoperability. It's not. Because of the backwards compatibility of H.264, and we've surveyed customers in terms of, what's the proportion of rooms in customers that only support H.263 and have no right to H.264, we found that this is entirely negligible, less than 1%. And you don't need H.263 for interoperability. So if you're told you need H.263, it's a misunderstanding. So this is our direction. It's going to be centered on the H.264 video codec family. We do H.264 as VC, but it gives us that backwards compatibility. We do have enhancements in signaling. It's important to understand that some of the things that I've shown you, such as the multi-stream is not just a static multi-stream, by the way. You can select which one you want to look at. If you want to look at, that person versus that person, You can select that on the fly. If you want to maximize the view, you can also do it. Those type of things require enhancements in signaling that go beyond the standard. So we document those. They're all documented on the internet and on TechNet, but they require some work on the signaling intermediation in order to plug and play with a legacy room that doesn't have those enhancements. In order to do this, there's going to be gateways, signaling gateways. Signaling gateways are not very costly. Transcoding gateways are very costly. There's going to be gateways from us and gateways from others, and I'll tell you more in a second on that. So, the way things will work with Link 2013 falls into the three categories. There's going to be qualified systems. Qualified systems are essentially, to oversimplify, a link client. They are a link client in the shape of a video conference room. A link room system is one such qualified system, but you have qualified systems potentially from the likes of Polycom or others. Yeah? And those qualified systems are so close to Link that they behave like Link, and they have all sorts of advanced capability, media control, quality management, and so on. You have compatible systems that will require some changes in the way the protocols are exchanged. And in order to do that, there's going to be a need for a video signaling intermediation. And then there's standard systems, which are just the ones that you typically have today. For example, a lot of Tandberg rooms would fall into that category. And we're going to need, sorry, I apologize. This one, there is not a need for a signaling gateway. They will do the change in signaling. However, there is not always the full support for all capabilities. Standard system, there is no support for our signaling protocols. There is no support for anything specific of the enhancements we've done. The way we work with them is through gateways that are signaling gateways. Signaling gateways will come from at least two vendors. Microsoft has announced a signaling gateway. It will be in prototype phase in the fall. So people who are part of the technology adoption program, those kind of things, will be able to have information on that and possibly implement it at that point. Cisco has announced an upgrade to their VCS, and we're actually working together on both of those things. Cisco has announced an upgrade to their VCS. That's their signaling gateway that will also support this. So you'll have two different views. They're different in the sense that the Cisco view is one that brings Link into a Cisco conference on the Cisco hardware MCU, which is very fine and normal, given what they're trying to do. It's absolutely no problem with that, but it's a specific experience. Link will be part of the Cisco conference. So for example, from a Link client, you won't see a list of participants. Just, you'll be in the conference. And you will need hardware MCU ports or whatever is their infrastructure in order to support that. The Link approach, the Link video interoperability server, will do just the reverse. It will bring the conference room into a Link conference. So you will have it on your, if you look at Link, you will see the participant, the conference room as a participant. I'm not trying to say good, bad, or indifferent. There's different approaches, different philosophies based on your assets, based on where you stand. It might make different sense. I think I'm going to pause here because I do have a couple more slides, but they're not that germane to the discussion. Pause and talk about video interrupt and take questions about video interrupt. We have another minute and a half or so. Questions about video interrupt?
What will be the next step? H.265 or?
So what will be the next step? H.265? At this point, the industry is very, very committed to H.264 SVC. We think we've only barely scratched the surface of what we can do with H.264 SVC. It's being implemented in all the mobile devices, literally right now, because the foundries are putting it in chips and so on. So we believe it's going to be quite a bit of time on H.264 SVC. It's not immediately obvious that there is that much of an advantage in H.265, in particular from a capability point of view. And the drawback would be that we destandardize something that we just worked very hard for the past 3-4 years to standardize. standardization is always a compromise. You know, when we used RT video, we had control over it, so we could always tweak it and make it better. And, you know, and it's possible that RT video in some way was better than H.264 SVC in some aspects, but it didn't have the interoperability. If we continue playing that game and trying to say, oh, H.264, H.265 is that much better, so we'll do it, and then we destandardize and we lose interoperability, we've broken the game. And so at this point, it's not that we're not looking at H.265, you know, because, you know, it's always interesting to look at everything, but we're very strongly committed to H.264 SVC, and we believe that's going to be, you know, the standard codec for the industry for a very significant period of time. The question around WebRTC actually is where things are very interesting, because if the consumer space and the browsers decide they standardize on a completely incompatible codec, the enterprise might eventually have to spend the money to go there, which would not be a fun game, but we may not have a choice if that's what WebRTC decides to do. So what you're talking about, more about IMS at this point. Right now, the way the video functions, on mobile device, at the chipset level, it's standardized. It's stage 264 today, and it's moving into SVC. The question is whether there's going to be a specific management of the video stream in the carrier. That's an IMS question. At this point, this is pretty much an over-the-top, you know, transparent thing, but that could evolve. I have no comments on that at this point. I've exhausted my time. I'm happy to stick around. People who want to leave, you're welcome to do so. That's very fine. But I'll stick around and take more questions. And I think, let me see. I think you asked a very good question there. And the next one, what is it? No? No more questions? Yes, there? I'm sorry, I can't hear you. I have to climb up because I go ahead.
Supported in Polycom products in the video side very well. How about the Cisco? Such realizing standards.
Yeah, so if I got the question right, the question is, so interoperability with Polycom works very well. What about the interoperability with Cisco? Yes. Yeah. So that's where, so Cisco rooms support H.264 AVC, or baseline codec, depending on how you exactly call it. H.264 SVC is compatible with that. Both Cisco and Microsoft are creating a signaling gateway, which will enable the native interoperability without transcoding or with very minimal transcoding between the two. When I say very minimal transcoding, there's extreme situations where some flows might require to be transcoded, but it's a very small proportion. So both vendors are providing a solution there. And you get a game, not a game, a device. Well, thank you very much. I'll stick around here, but I've exhausted my time, so I want to be mindful of that. I appreciate your attendance today, and I'll stick around.